Hello everyone, myself Pushpalata. I'll be discussing about wired LANs which are so called Ethernet, and this is a chapter 2 of module 2. The syllabus of Ethernet is as follows. It comprises of wired LANs, Ethernet evolution, the types of Ethernet. Basically there are different types of Ethernet: standard Ethernet, fast Ethernet, gigabit Ethernet and 10 gigabit Ethernet. What are the characteristics of those types of the Ethernet and its application will be seen in this particular chapter. Basically, Ethernet protocol, the TCP/IP protocol does not define any protocol for the data link or the physical layer. The protocols which are being supported at these two layers are provided by the TCP/IP. They accept any protocol at these two layers that provide services to the network layer. The data link layer and the physical layer are actually the territory of the local and wide area networks. Now, considering the Ethernet, in 1980s and 90s, there were several different types of LAN were used. All of these LANs used a media access method to solve the problem of sharing media. Now, Ethernet used CSMA-CD approach, as we have already discussed about CSMA-CD and CSMA-CA, and the Ethernet used CSMA-CD approach. Now, as we know about the Ethernet, they are the wired LANs. They accept the Ethernet. Okay, almost every LAN except the Ethernet, they has disappeared from market right now because Ethernet was not able to update itself to meet the needs of a time. And any organization right now in the industry as considering the industrial revolution, Ethernet LAN is it was basically a past. Now it needs an higher data rate, and that would update the new generation instead of switching on to other technologies, which would cost you much and the time consumption will be more. So basically Ethernet LAN was there was a requirement for improvising the data rate of the Ethernet. Now, for which the IEEE thought of a project which is defined as in Project 802. In the year 1985, the Computer Society of the IEEE, they started a project called Project 802, and to set the standards to enable the intercommunication among the equipment from variety of manufacturers. And this project never asked for replacement of the OSI or TCP/IP model. Instead, it gave a way for specifying the functions of the physical layer and the data link layer of major LAN protocols. And the IEEE has subdivided the data link layer into two sublayers. Those are LLC and MAC, logical link control and media access control. Earlier, the data link layer was being segregated into data link control and media access control layers. To standardize, the IEEE has created two layers which are nothing but logical link control and media access control. IEEE has also created several physical layer standards for different LAN protocols. And LLC, as we have already dealt about LLC, their duty is to provide services. And here also in IEEE Project 802, the services provided by the logic link control are flow control, error control, congestion control, and also some of the part of the framing duties are being handled by this logical link control. Now let us talk about these two layers, that is media access control. As earlier we have discussed multiple access methods, like including random access, which different types of random access we analyzed, that is Aloha, pure aloha, slotted aloha, then CSMA, CSMA CD, CSMA, and the control access methods like reservation, polling, token passing, and channelizations. So these are the different types of multiple access methods, and IEEE 802 has created a sublayer called media access control that defines a specific access method for each LAN. Say for example, we know that the Ethernet defines CSMA CD approach, and the token passing method for token ring and token bus LANs. A part of the framing function is also handled by the MAC layer. Now consider the IEEE standard for LANs. Like as in case of OSI or TCP/IP suite, the two different layers, the bottom two layers were the data link layer and the physical layer. But as according to IEEE standard, they considered the data link layer to be of two sublayers. One is of LLC, other one is a MAC. LLC is a logical link control and media access control, which is individually meant for different physical layers. Say for example, if it is an Ethernet MAC, the physical layer would be the Ethernet physical layer. If it is a token ring MAC, then the physical layer would be a token ring physical layer. Or else if it is a token bus MAC, and the physical layer would be a token and token bus physical layer, so on. So the MAC provides services according to the physical layer which are connected below the data link layer, and this was been specified by the IEEE standard for LANs. Now to proceed, how the evolution of Ethernet took place. Basically, it was developed in the year 1970s by Robert Metcalfe and David Box. Since it has gone through 4 generations right now, there are different types of Ethernet you could see. One is the basic standard Ethernet, which the data rate was 10 Mbps, and to proceed with, we have fast Ethernet of 100 Mbps capacity, and gigabit Ethernet of 1 Gbps, and 10 gigabit Ethernet of 10 Gbps. And the Ethernet evolution chart is, or the block diagram is shown below, how the evolution of these through these 4 generations have taken place. Now consider the first type of the Ethernet, that is standard Ethernet. Basically here we refer to the original Ethernet technology with, this is the original Ethernet technology with a data rate of 10 Mbps. Although that the implementations have moved other technologies in the Ethernet evolution, only few are being still retained. Though that all the features were being improvised, few as a part of Ethernet is being retained because of the advantages what standard Ethernet had, and it paved the way for the remaining other 3 technologies. Now, what are the characteristics of this standard Ethernet? The characteristics is basically it is connectionless and unreliable service, and here connectionless is basically meant that the frames are independent, they are not dependent on each other, or a frame is independent of the next or the previous frame. That is what is the connectionless means. So Ethernet provides a connectionless service, and Ethernet has no connection establishment or connection termination phases. That means we don't have any startup or end up process. Okay, so Ethernet has no connection establishment or connection termination phases. The sender sends a frame whenever it has a frame to send. The receiver may or may not be ready for it. Sometimes the sender keep on sending the frames, and the sender may overwhelm the receiver, which may result in dropping of the frames at the receiver, and even the sender will not know about it. Since the IP which is using the service of an Ethernet is also connectionless, it will not know about it either. Next, suppose if the transport layer is also connectionless, say for example, instead of using a TCP, such as if UDP is used, which is the connectionless protocol, the frame is lost and the salvation may only come from the application layer, since because no acknowledgement is received when you are using an UDP protocol. However, if the transport layer is a TCP, the sender TCP does not receive acknowledgement for its segment and sends it again. Okay, so Ethernet is also unreliable like IP and UDP. Considering if the frame is corrupted during the transmission, the receiver finds about it the corruption, which has an higher level probability of happening because of say for example CRC is not matching. The receiver drops the frames immediately or silently. Now it will not acknowledge if it is a connectionless protocol. Now it's a duty of an higher level protocols to find out about it, and that could be happened maybe at application layer. Now consider the frame format of standard Ethernet. The standard Ethernet comprises of 7 fields. The Ethernet frame begins with a preamble. That preamble is of 56 bits of alternating ones and zeros. So which is nothing but 7 bytes of the preamble is included as a beginning of a Ethernet frame, followed by 1 byte of start frame delimiter. In short, we can call it as an SFD. SFD comprises of a starting delimiter or a flag, and you can consider as an example of 10101011, which is shown in the picture. Next, followed by, it is a destination address and the source address. The destination address is of 48 bits or 6 bytes length, which addresses which is the destination of link layer address of the destination, and similarly the source address is a link layer address of the source from which the frame has been sent. And the type is of 2 bytes, which tells what type of protocol that is being used, whether it is IP, ARP, etc. Next, to followed by the type, it is a data and padding. Data along with the padding, because the minimum frame length here we consider is 512 bits or 64 bytes. In that 64 bytes, the minimum payload length to be equal to 46 bytes. That means the data minimum length should be 46 bytes. In case if the data is less than that 46 bytes, then you have to make, a sender has to make equal to the length, the minimum payload length as 46 bytes by padding the number of zeros such that it becomes equal to 46 bytes, and the maximum payload length, it is equal to 1500 bytes of data length. In case if it is exceeding, then it has to be segmented as another frame. Now along with the data and padded with zeros, the followed by CRC, it's a cyclic redundant check, which is of 4 bytes of length, and that is for error checking. And in case if CRC is matching, then the data is correct and it can be sent to the above layers at the receiver. Now the total minimum frame length, apart from the preamble and the starting and delimiters, the minimum frame length to be equal to 512 bits or it is equal to 64 bytes, and the maximum frame length to be equal to 1518 bytes, because the maximum data length is of 1500 bytes plus 18 bytes is the other informations, which includes the preamble, SFD, address and type, and also along with that CRC. Next, to move on further, this is the frame length. Ethernet basically has imposed restrictions on both the minimum and maximum length of the frame. An Ethernet frame needs to have a minimum length of, basically I told you, 512 bits or 64 bytes, and the maximum of 1518 18 bytes. The data length to be 46 bytes and the maximum data length to be 1500 bytes. So let us continue this topic in further session. Thank you all.